part of complex analysis, where our part A we did the introduction of complex analysis in terms of complex numbers, and right now we'll be continuing with the example series of complex numbers in complex analysis. Okay, now let us have another example based on this one, because on the first video we did 2 questions, and now let us find another one. Or let me see this one now. In the previous one we were asked to write the complex number in exponential form. Now they are giving us something, a complex number, yes, but this complex number has to be written in rectangular form. Okay, now we need to see what is going to happen to. Okay, let's just solve it. Okay, now let us have the solution for this. Now if you look at this nicely, guys, okay, you will see that, right, looking at this, guys, we need to see. Okay, let us start by writing it in exponential form. Okay, now we have that, and now let us find our r. Okay, we know that our r is given by the square root of this one squared, which is gonna be the square root of 3 squared plus 1 squared. Okay, now that's what we have there. So the square root of 3 squared is just 3, square root of 1 is just 1, so it becomes square root of 4, which is equals to 2. Okay, so we found our modulus. After finding our modulus, we will want to find our argument. Okay, now let us find our argument. First thing first that we need to remember is that cos of theta is equals to x over r. What is our x? Is the square root of 3 all over 2. Now in this case we can find our theta by finding arg cos of that, where our theta will be just pi over 6. Okay, it's a special angle. Okay, so let's see what's going to happen with sine of theta, which is y over r. So y is given by 1 over 2, which our theta is equals to pi over 6. Now this is a beautiful example. Easy. Now I want us to look at this idea now. So you can see that now we have our value of theta there. Now I want to show you something, guys. This square root of 3 plus I is equals to now according to that is going to be 2e to the I multiplied by pi over 6. Okay, which is just 2e I pi over 6. Right, but we didn't write this. Okay, so now the root of 3 plus I to the 7 is equals to, now we're gonna have the same thing, 2ei pi over 6 and everything multiplied by the power of 7. Okay, this will just be 2 to the 7, and then you're gonna have ei 7 pi over 6. Okay, now what's gonna happen next is that I'm gonna try to take out this from whatever that I have here. What I mean is I can rewrite this as 2 to the, or 2 multiplied by 2 to the 6. Okay, and then have e to the I. Now I need to find, or I need to separate this in terms of what do we call this, in terms of I pi to the 6, or I pi divided by 6. Okay, now when I look at this nicely, 7 over 6, I can just say, okay, this can be rewritten as I pi, okay, multiplied by I pi over 6. Now somebody might say to me, so how do you know that that is true? Okay, now I want you to look at the fact that pi can be rewritten as 6 pi over 6. Okay, and then when we add that pi over 6, it's going to give us something like this. Now 7 pi over 6 will be just 6 pi over 6 plus pi over 6, which is just 7 pi over 6. Okay, so I just killed both of them and then had what I have here. Okay, now this is what we're gonna have here, guys. Okay, now I'm gonna separate all these terms now. So I'm gonna have this, which is 2 to the 6, okay, and have ei pi multiplied by 2 multiplied by e. Oh, let me not write it as multiplication. Let me just have it as 2 ei pi over 6. Okay, now this is now we know what this term is. Okay, this term is just what we have here, right? Because this and that are exactly the same. So this is what we're gonna have here. So 2 to the 6 is just 64, and then here we're gonna expand this using Euler's formula. Okay, so we're gonna have cos of pi plus I sine of pi, okay, multiplied by what we have here, which is just the square root of 3 plus I. Okay, now what is cos of pi? Now cos of pi is just -1. Okay, let me show you here. We just draw this here, our little diagram that we can always take. This is sine, this is cos. Okay, now if you check closely, this is 0, this is pi over, oh, this is pi over 2, this is pi, this is 3 pi, and this is 2 pi here. Okay, and this is 0, this is pi over 2, this is pi, and this is 2 pi. Now cos of pi is -1. Okay, and then sine of pi is just 0. So we're gonna have now 64 minus times -1 plus I times 0 multiplied by the root of 3 plus I, where this is just -64 multiplied by the root of 3 plus I, which is our final answer. Okay, then we can say now, therefore, the square root of 3 plus I to the 7 is equals to -64 square root of 3 plus I. Okay, so we've written this in rectangular form, or rectangular coordinates, whatever you want to call it. Okay, so this in rectangular coordinates is just equals to that. Okay, so let me have another example. Okay, let me remove this. Let me have another example. So let us write this one in rectangular form. Okay, now is the same ideology that we're gonna use here. We're gonna convert this to exponential, then exponential. We'll see what happens with that. Okay, now let us have the solution to this. Now we know by now that we can find our modulus, which is the square root of -1 squared plus 1 squared, which is just the square root of 2. Guys, from now I'm just gonna skip this part. I'm just gonna write the solution straight, because I believe now we know how to find the modulus. Okay, I believe that now we know. Now we're gonna have cos of theta is equals to -1 over root of 2, and then sine of theta is equals to 1 over the root of 2. Now okay, let me just find, first thing first, with the theta one, with the cos of theta, we're going to have that our theta is -pi over 4. Okay, and then with the second one, we are going to find out that our theta is equals to pi over 4. So we got -pi over 4 and pi over 4. Now how do we solve this? Now we look at our trig functions, sine and cos, and then I draw that little cast diagram. Okay, So I have it here. Here's my cast diagram. Now we know that in the first quadrant all of them are positive, but in this case we want to know where sine is positive and cos is negative. It's in the second quadrant, so which means the angle that is going to lie there is going to be the angle that we are going to use to define this thing. Now what happens is that we are going to have, now we know that in the second quadrant we have that the angle pi minus theta. Okay, so we have the angle pi minus theta. Now our theta in this case is given by pi over 4. Now we're going to have pi minus pi over 4, which is going to be 3 pi over 4. If you can check 3 pi over 4, let us find cos of 3 pi over 4. It's going to give us negative of 1 over root 2, and then sine of pi over 4 is going to give us a positive of 1 over root of 2. Okay, check it guys, please. Now for us to continue, we have our angle theta, we have our modulus, then therefore minus 1 plus I is equals to the modulus EI, and what is the angle? 3 pi over 4. Okay, this is what we have. This is our solution. Okay, but we didn't solve the question. Now we are solving the question. Now we are looking for negative 1 plus I to the 7. This is going to be the square root of 2 EI 3 pi over 4 to the 7. Now you're going to understand why I write it like this first. Okay, I want you to look at the pattern and comment down below what is the pattern that you're seeing there. Okay, now from here we are going to multiply each and every term by that exponent. So what I mean is, here I can write this as 7 over 2, because that is that, and then have EI to the 21 pi over 4. Okay, because I know that 7 is not divisible by 4. Now I'm gonna do the same thing, try to find what this is from here. Okay, that's what I do. That's the only thing. Now what's gonna happen is I'm gonna have minus 1 plus I to the 7. Now for me to recreate that 7 over 2, I can write it as 2 to the 3 multiplied by 2 to the 1 over 2. Check that guys, please. Okay, please check that, confirm whether I'm correct or not. Okay, now the second part is the 21 pi over 4 part. Okay, now I'm gonna do the same thing, try to find what? Pi over 4. Now what's gonna happen is I'm going to have e to the I and have 5 pi, okay, 5 pi multiplied by e to the I pi over 4. Now somebody will ask, but you said that we have 21 pi over 4. If you multiply this by 4 and divide it by 4, it's going to be 20 pi over 4, which when we add to that becomes 21 pi over 4. Alright, so we don't need to stress too much about that. Now let us continue. If you can look at this guys, we are going to write this as what? 2 to the 3 2 to the 3 e I to the 5 pi multiplied by 2 to the half, which is just the square root of 2. Let me just write it as the square root of 2. The square root of 2 e I pi over 4. Fair enough, right? Fair enough guys, fair enough. Now let me treat them individually. Now let us have the first one, 2 to the 3 e I 5 pi is equals to 8, which is 2 to the 3 cos of 5 pi plus I sine of 5 pi. This is in the bracket, so this is just equals to, because we know that this is going to be negative 1 and this is going to be 0, so we're gonna have negative 8. Okay, that is our first solution. But now you see that we cannot have negative 1 minus I because it has this angle 3 pi over 4. So which means we are forced now to look at what is the square root of 2 multiplied by e Oh, it's not multiplication actually. Sorry guys. So it's going to be the root of 2 cos of pi over 4 plus I sine pi over 4. This, now we know that cos of pi over 4 is just 1 over root 2. And then, okay. So it's going to be root 2, 1 over root 2 plus I 1 over root 2. So this will just become now, this square root of 2 e I pi over 4 will just become now, this multiplied by that is just 1 plus I. Okay, now if you can remember well, this minus 1 plus I to the 7 is equals to multiplication of the 2. So it's going to be minus 8, which is the first one coming from here, multiplied by the second one, which is just 1 plus I. So the solution is given by there. Okay. Now we have seen that we can write our powered or our exponent, that term, our powered terms into rectangular form. Okay, so it is easy for us to change it into rectangular form using what? Exponential form. So there is importance on the relationship between rectangular form and exponential form. Okay, now let us look at an example which is trivial. It is nice, it is beautiful. Okay, now if you don't understand guys, please do comment below and I will reply. Definitely I will reply. Let us look at example which most of our textbooks like. Okay, for instance, this textbook I'm using likes this question very much. Now they say we have to prove that this is true. Okay, and this whole idea comes from the guy called De Moivre. This is what we call it, the De Moivre's formula. Now we need to prove that this is equals to that. We can either start with the left hand side or the right hand side. It really doesn't matter. Okay, so let us have the solution down here. Let us start with the left hand side. Okay, left hand side, we've got cos of theta plus I sine of theta squared. Okay, now this can be rewritten as, oh sorry, I used the wrong one. This is cos of theta plus I sine of theta squared. Okay, this is just equals to cos of theta plus I sine of theta cos of theta plus I sine of theta. Okay, now if you look at these guys, now we multiply the two. Cos times cos becomes cos squared theta. Cos times this one becomes I sine theta cos theta. This times that, I sine theta cos theta. And then this times that becomes minus, because I times I times I is equals to I squared, which is equals to -1. Okay, so sine times sine is sine squared theta. Now I can rewrite this as cos squared theta minus sine squared theta plus this plus that, it becomes 2i, or we can write this as, because now I is common, we take it out and it becomes 2 sine of theta cos of theta. All right, now if you can remember well from trigonometry, we have this idea guys, that cos of 2 theta is equals to cos squared theta minus sine squared theta. Now we're gonna use this idea guys, and we know also that sine of 2 theta is 2 sine theta cos theta. Now if you can check, both of these trigonometric identities are present there. The first one is here, so we can replace it with that. So you're gonna have cos of 2 theta plus I sine of 2 theta. where this is equals to our right hand side. Okay, so there is nothing which I believe might be hard about this question and proving it. Okay, but if you feel like you need more explanation based on this, please do let me know in the comment section below. I will try to explain it in a very, I don't know which term I can use, but in a way that is very understandable. Okay, if you came this far, guys, please hit the like button, please subscribe, guys, please also share the information that is shared here, and please, guys, just get more people such that we can be able to give help to those who need help with mathematics. And thank you, guys.